Hey, welcome to the second video on 6.1 where we're studying the composition of functions. Um, in this video, we're going to talk a little bit about what the domain of a composed function is. And we'll open with an example. So let's stick with a classic one. F of x equals the square root of x, and g of x equals x squared plus 1. And let's ask what is the domain of f composed g of x? And probably the first step we want to do is actually figure out what f composed g of x is. Review the first video if you need to, but I'm going to quickly write down that f composed g of x is the square root of x squared plus 1. All right, and now we want to figure out the domain. That is, we want to figure out all real numbers that we can plug into it that give out real numbers. So individually, we know that the domain of f is all the positive numbers. If we plug a negative number into f of x, we're going to get an imaginary number out. Well, it's fine for some parts of the course. This is one where we're still going to think about our domain as just outputting real numbers. And the domain of g is a polynomial, so it, of course, is all real numbers. Okay, so we can think about this in two steps. One, we want to plug in numbers. To plug in numbers x so that g of x is real. Okay, so that's going to tell us that if g of x isn't real, then that's going to be excluded from our domain. So let's then notice that then the domain of f composed g is a subset, of domain g. That is, if we plug a number, if a number is in the domain of f composed g, then it's also in the domain of g. And if a number is not in the domain of g, then it is not in the domain of f composed g. 2, we want numbers x where g of x is in domain of f. So that should hopefully make sense because we're plugging in g of x into f. So we want g of x to be some number that's in the domain of f. Therefore, we have to restrict domain to the set x where x is in the domain of g and g of x is in the domain of f. So that's a little bit of set theory notation there, but all it's saying is that this set is the set of x where x is in the domain of g, and when we plug in x into g of x, we get something that's in the domain of f. So for our example, continued, our domain of f composed G equals all of our real numbers where x is in the domain of G, which is all real numbers, and G of x is greater than or equal to 0. So that's what it means for G of x to be in the domain of f. The domain of f is all the numbers that are greater than or equal to 0. So we're just looking for where G of x is greater than or equal to 0. And then note that G of x equals x squared plus 1, which is always greater than or equal to 0. So the domain of f composed G is going to be all real numbers. Plug in any real number, G of x is going to turn it into some positive number, and then we just square root it. So everything's going to work out perfectly. There are, of course, cases where things don't work out perfectly. So for another example, we can have f of x be the square root of x again. G of x equals negative x. So then the domain of f, from above we knew it was 0 to infinity. And the domain of G, since it's just a linear function, is still all real numbers. But the domain of f composed G is the set of real numbers in R where x, put this condition here because that's just still saying that x is in the domain of G, and G of x has to be positive. All right, well, G of x takes a number and turns it into its negative. So that implies that this domain of f composed G has to be all the numbers from negative infinity to 0. Because we plug in a positive number into G, it's going to turn into a negative number, and then we can't take the square root of it. But if we plug a negative number into G, it turns it into a positive number, and then we can square root it just fine. All right. I hope this video was informative. Now we're going to move on to section 6.2. All right, see you in the future videos.